In this video, we're going to discuss about what is leftmost derivation that is called as LMD and what is rightmost derivation that is called as RMD. Myself Sharmila, working in the CS department in RMD Engineering College. In today's video, we're going to discuss about LMD, RMD, and then parse tree. What is parse tree? So LMD, before going to LMD, RMD, and parse tree, first we'll shortly discuss what is context-free language. That is called as CFL. CFL is C for context, F for free, L for language, context-free language. The collection of language generated by some context-free grammar are called as context-free language. Here there are type 0, type 1, type 2, type 3. There is a 4 types of grammar available in the theory of computation. That is regular grammar, context-free grammar, context-sensitive grammar, and recursively enumerable grammar. They include all the regular languages and many different addition recursive structured languages. Here, the regular language, you know what is regular language, that is R, the language represented in the regular language, and context-free grammar, that is context-free language, is a collection of language generated by some context-free grammar called as context-free language. Then context-sensitive language, that is called as linear bounded automata, and one more is recursive enumerable language, that is a Turing machine. You know what is a Turing machine? Off and on that particular situation, how it works. That is a recursive enumerable language. Here we are discussing about context-free grammar in the leftmost derivation. The leftmost derivation, that is LMD. We are doing the derivation for the string W in a grammar G, leftmost derivation. If at every step leftmost remaining variable is the one replaced, wherever we want to replace the variable, that particular grammar, in that particular grammar, variable replacing only in the left side means that is called as leftmost derivation. For example, they have taken a tuples v sigma r, that is expression, that is start state yes. You know what is v variable, sigma is a terminal, r is a rule for that context free grammar, and that start symbol is here is expression yes. So we are deriving the rightmost derivation. The rightmost derivation is a string w in a grammar G is a rightmost derivation if at every step the right remaining variable is the one replaced. So the grammar is v sigma r expression yes. So we are replacing the rightmost variable in the one we replace. That is called as rightmost derivation. The example for LMD is given here. They have taken a grammar E tends to E plus E. Here we are replacing for the first E the derivation ID, identifier ID. So E the leftmost value, so we are replacing it as ID plus E. Next, that is a that E is there. For that E, we are again replacing E tends to E into E. We have a second production, so E tends to E into E. We are replacing in the place of E into E. Again, for this second E, we are replacing ID. Again, for the left side, there is one more E is there for that ID. So the expression is ID plus ID into ID. So this is derived from leftmost, from the left side value. So it is called as LMD. Next one is RMD. In the same grammar, we have taken E tends to E plus E, E is into E and ID. We are first replacing the E, that is from the rightmost value. You can see the difference. This is from right side. What we have seen in the leftmost is from left side. So in the rightmost expression, we are replacing that right side, E tends to ID, and then the second E tends to ID, and the first E tends to E plus E. So we are writing expression is ID plus ID into ID. From left side, right side, we are moving the expression and we are framing the tree. So that is called as RMD. For this LMD, RMD, this grammar, we are writing a parse tree. Parse tree is nothing but it's a derivation. It's a tree-like structure. The we have a child node and parent node. Parent node will be always that particular terminals, and the child node will be its variable. The parent node will be a variables and child node will be a terminals. That here the variables are capital E ID, correct? And that child node is a multiplication plus comma whatever they are given the expression operator. This is called as leftmost derivation. What we have done in the LMD, from left side we have done an expression, correct? Same thing we are applying here. The first E we are applying ID. For the second E we are applying E into E. Again in that first we are applying ID and then second we are applying for this ID. So it is from left side. So it is called as leftmost parse tree. This tree is for right side. In the first we are applying for this E, we are writing as ID. For this E, we are writing E plus E. For this first second E, we are writing ID, and the first E we are writing ID. So from right side we are deriving the expression is called as rightmost derivation. That derivation we are drawing a parse tree, that is called as rightmost derivation parse tree. So here we are checking the ambiguity rule. Here what is the ambiguity rule means? More than one LMD is formed, then it is called as grammar is called as ambiguous grammar. More than one RMD is formed, that is rightmost derivation formed, means that is an ambiguity expression. Then more than one parse tree can be generated from a given input string. If we are generating only one, means that is not ambiguous. If we are generating more than one parse tree from the given input string, means that is called as ambiguity grammar. So here for the given question, they are deriving LMD or RMD, two different parse tree. The grammar is ambiguous grammar. Okay, that's why it's called as ambiguous grammar. So what we have discussed in this video is what is leftmost derivation, what is rightmost derivation, what is parse tree, what is leftmost parse tree, what is rightmost parse tree, and what is ambiguity, what is ambiguity rule. The ambiguity rule is the grammar should be ambiguous, means more than one LMD, more than one RMD, more than one parse tree can be generated from the given input string. So we'll see in the next video what is that expressions. Okay, thank you.